Yes. You didn't get it?
Oh. Okay. Huh? Ah, there you go. Right. I don't think there was anything too hard in this first lesson. I hope not. So let's have a look at the first one. A copper wire carries 4 amps of current, and the copper runs through a magnetic field so that the copper is perpendicular to the field. It's 40 centimeters long and there's a flux density of 6 Tesla. How big is the force? So what formula is this? It's just Bill, isn't it? Oh, my calculator hasn't loaded yet. So it's going to be 4 times 6 is 24 times 0.4. What's that? 9.6 newtons? Yeah, okay, 9.6 newtons for the first one. And then for the second one, if the angle is 70 degrees, it's 9.6 times cos 70. Let me think, I don't know, 8 newtons? Cos. No, sine 70. So what's it about, 8 newtons or something? Huh? That much? Alright. 4 times 6 times 0.4 times sine 70. Okay, 9.02 newtons. Alright, so first question's fine. Yep. Now, let's see the next one. A DC motor, 2 amps, 6 Tesla, 2000 loops, 30 centimeter length. What's the torque?
MBA.
No? Which formula? IBAN.
Yeah,
IBAN. So what's that? 2 times I times B times A times N. Yeah? 2,160 Newton meters. Yeah? So again, easy peasy. A coil is wrapped around an iron rod 200 times. What's the flux linkage? So what formula is that now? That's the MBA one, isn't it? So what's that now? 200 times N times B times A, which is pi r squared. Did you get 18.85 Webers? Yeah. And if there's an angle of 20, then we times this by cos 20, and the final answer is 17.7 Webers. Yeah.
Can you explain again what makes the cos?
Why is it cos?
Yeah.
Do you want the easy or the hard answer?
Medium.
No. It's only 2 choices. Huh? Easy one is that's what's in the formula in the formula book. Too easy then, is it? So it's like this. Let me open up. Where's my right? There it is. So let's imagine we have our field like this. And I wonder if I miswrote that, because I should be talking about the normal, shouldn't I? Yeah. With the rod. Yeah. Anyways, what I meant here, usually, the formula is NBA, and what you really care about is, in this case here, this is 3 Webers cutting it. Okay, but now, let's suppose instead we have an angle. So it's at an angle here. Then it's actually just this component you care about. So in the formula it's NBA. Let's forget about the N for the moment. It's just BA. So here this is the A. In this example, it's not this A we care about. It's only the A that's perpendicular to the field. So that one here would be A cos theta, where the theta is
there. Okay, there.
no hold.
Okay.
Give me a moment,
Yeah.
please. So the theta is, I need to draw a triangle, okay? There's my triangle. This side is the A. So this here is the theta, which makes this here the theta. So it's the angle here with the field. I think I have that right. Yeah.
A has to be perpendicular to the field.
Yeah. So like here, this is fine.
Yeah.
But if it cuts the field at an angle, then it's actually only this part of it you care about, because this side here of this, it doesn't intersect it, you know.
Why the angle is there? Why angle is there?
Why here?
Yeah.
Or why here?
No, they are saying.
Here. Yeah, that's the same, yeah. We measure the angle it makes with the field, don't we?
Isn't that sine?
There is sign.
Hang on, don't confuse me, I'm tired. Oh, you're right, sorry, you're right.
Okay.
I had an exam this morning, you see, so I'm very tired, because I was preparing for it last night. Computer exam. Right, let me just try this again. Apologies. Okay. Right. There's the field. This is the normal situation. But that's not what we have here. Instead we have it at an angle. And the way we usually measure the angle is the angle the normal, which is this, makes with the field. Okay, so we call this theta. That's just how we measure the angle. In my question, it was very bad. I said it's 20. I really meant this is 20, not that this here is 20. Anyway, just continue with this. So this is the normal. This is the plane. We measure the angle with the normal and the field. So if we were to draw the side we care about this side. And we don't care about this side, because this is parallel and this is perpendicular to the field. So that's 90. Where's the theta here? Let me think. If that's theta, then that one is 90 minus theta. If that's 90 minus theta, that's 90 minus theta, which makes this one theta. And because this is the side with the theta, it makes this one the cos. So a cos theta there. And you're right, this side should be a sine theta, I apologise. But this one we don't care about because it's parallel with the field. There's only the perpendicular side we care about. Yeah, I think this picture is much better. Do you need to draw this picture down? Yeah. Area. Yeah. It's hard to picture this in 3 dimensions, but if you imagine it like this, it's kind of like I have an area. Oh, how can I draw this in 3 dimensions? That's not too bad. But I'm just looking at like one side of it. If I could project the side down, and I could project the side across, maybe I only care about this one because the field is coming this way, you know. It's a bit like resolving. I'm resolving the area into 2 parts. We only care about the area where the field is perpendicular to it.
So theta, they always give it.
Yeah, they always give it as the one for the normal anyways. That's why there's a mistake with my question. I should have said that in it.
And for the f0 sine theta, the current has to be perpendicular to the b, basically.
Yeah. There's not a mistake here, is there?
How's the blue one theta?
How's the blue one theta? Good question. Okay, so this is theta. That's given. This is 90 minus theta. Agreed? Agreed? So this is also 90 minus theta. Agreed?
Why?
Why? Because you have this in maths. This is the same as this.
Oh.
And if that's 90 minus theta, then this is 90 minus 90 minus theta, which is theta. Yeah? It's in my head what I did was 90 minus 90 minus theta is this one. If that's theta, this one is 90 minus theta, because the total is 90. And this one here is the same as this one. Is that okay? It's from geometry, you know. Okay. You don't like it? You like it? Is it cute? Okay.
Looks like puppy.
Alright. We have this. I can close this one, go to the next lesson.
Yeah.
Yep, okay, so